Hi, in this video we will introduce a new indeterminate form, product indeterminate form, where you have 0 times infinity. Well, if I want to put it in a precise wording, I have two functions, f and g, and the limit of f as x approaches to a is 0. Limit of g as x approaches to a is either plus or minus infinity, doesn't matter. So one is growing big and big, and one is getting smaller and smaller. Each one we know how to deal with, but when you multiply a very big, growing large number to a growing very small number, then there is a struggle between these two. Which one takes over? And well, we have to be careful in these cases. That's why we call these guys, this format, indeterminate form of type, well, product type, which is 0 times infinity. Well, these will appear very naturally everywhere. For example, if the limit of x times ln x as x approaches to 0 plus. You see the limit of first function here is x. As x approaches to 0 is 0. Limit of ln x as x approaches to 0 plus is negative infinity. So this is an indeterminate form of type 0 times, well, let me write negative infinity just to emphasize that it's negative infinity. Well, how do we resolve these cases? Well, the key point, the key trick is that we turn these indeterminate forms to either 0 over 0 or infinity over infinity indeterminate forms. So to resolve these indeterminate forms, well, what is the trick? The trick is that you can write f of x times gx either as gx over 1 over 1 over f of x. So 1 over 1 over f of x is f of x. Or you can write it as f of x times gx. You can write it as the other way around. You can write it as f of x times 1 over g of x, or over 1 over g of x. And why is this important? Well, by writing this, the limit now turns to limit of f of x gx, which was 0 times infinity. Now it is of the form g of x over 1 over f of x, which is, as x goes to a, this guy is 1 over 0, which is infinity. This is infinity. So you will get infinity over infinity. Or if you use the other one, you will get limit of f of x gx, and you will have this guy as x goes. So g of x goes as x goes to a is infinity. 1 over infinity is 0. So this will be 0 over 0. So by writing that, we turn these guys to quotient indeterminate form. So turn them to either 0 over 0 or infinity over infinity in indeterminate forms. Why is it important for us to have 0 over 0 or infinity over infinity? Well, because we have a strong tool, L'Hopital's rule. Then we can use L'Hopital's rule to find the limit. So you do that trick, turn it to 0 over 0 or infinity over infinity, and then you will have the strong tool, the tank that will be used to find the limit. Okay? Let us do some examples. This one. So first thing first, to see that what kind of limit is this. Okay, limit of sine inverse of 2x as x approaches to 0. This is 0. And limit of cosecant x. Remember, cosecant is 1 over sine, yes? And 1 over sine when x approaches to 0 is going to be negative infinity. So we have negative infinity. Now, you can either do 1 over sine inverse of 2x or times cosine x, or let me write it here, limit of 1 over sine inverse of x times cosecant x, or you do limit of sine inverse x 1 over cosecant x. Well, I didn't say which one is the best one. You have to look case by case. In this case, as you see, well, sine 1 over cosecant x is sine x. So then this will turn into this limit. Oh, there was 2x somewhere, yes. These were 2x. And this guy is also 2x. And this is also 2x. Well, by turning that, you see that this will give us better function compared to this one. 1 over sine inverse is not sine. You have to be careful. Yes, and the derivative of this guy is more complicated case. So I will go with this one. So I will choose this one. And what does that give me? This gives us a 0 over 0 indeterminate form. Yes, and then we can use L'Hopital's rule, which gives me our limit of x goes to 0 minus derivative of sine inverse of 2x is 2 over root 1 minus 2x squared. Derivative of sine x is cosine x. Now, when you let x goes to 0, let me just clear these ones here. We will get cosine x times 1 minus 2x squared. Right away, you see that the limit of the denominator is 1 times 1 minus 0, which is 1, and then the numerator is 2. So the limit is equal to 2. Product indeterminate forms, you have to turn it to the 0 over 0 or infinity over infinity. This will be infinity over infinity. But we chose to go with 0 over 0. Why? Because in this case, it was easy, and you have L'Hopital's rule to resolve that. Well, again, here, we just check this guy. This is 0 times infinity. Which one we choose? Are we going to do ln x over 1 over x? Or you would do x over 1 over ln x? Well, one thing that would help you to figure out the right one is that, well, one of these guys will give you easier derivative of numerator and denominator compared to the other one. So in this case, I will go with this one, which actually is negative infinity over plus infinity, infinity over infinity, and I can use Labtube's rule, which gives me derivative of ln x is 1 over x, and derivative of 1 over x is negative 1 over x squared. Very nice. And then, well, if you can simplify algebraically at any stage, go ahead, do it, please, because that will simplify the functions you're working with. For example, this goes with that, and we get minus x over 1, and as x goes to 0, this is 0. We only use once the L'Hopital's rule, and then the whole limit is equal to 0. Here we have a little bit more general case. I have x times sine of a over x as x goes to infinity. You see, limit of x as x approaches to infinity is infinity, and limit of sine of a over x. If a is any non-zero number, then a over infinity, so 1, 2, 3, 10 over infinity is going to be 0. Sine of 0 is 0. So we have infinity times 0 case, which is product indeterminate form. And what do? We turn one of them as 1 over 1 over. In this case, better to do x as 1 over 1 over x. And then in the numerator, we have sine of a over x as x approaches to infinity. Now, if you check this, this will be 0 over 0, and we can use L'Hopital's rule. This will give me derivative of sine of a over x. It will be negative a over x squared. Sine of u, the derivative is u prime, so this is derivative of a over x. Then cosine of a over x, and this one is negative 1 over x squared. Sorry, this is infinity. Now you can simplify, as I said, as I always mention, you can simplify, don't wait for anything, because that will make our life easier. And you have this as x approaches to infinity. Now you see a is any number, non-zero number. Cosine of a over infinity, this is 0, and this is a times 1, which is a. So whatever we put there, that will come out. How about this last one? Here, the derivative, sorry, not the derivative, the limit of cosine of 3 pi over 2 is 0. And what kind of 0 is that? It is actually 0 negative. And for this guy is also, so it will be positive, positive infinity. Secant is 1 over cosine, yes? So again, we have 0 times infinity indeterminate form, and we have to turn it to either 0 over 0 or infinity over infinity. Which one is better to do? You see, secant itself is 1 over cosine. So if I do 1 over cosine, it will give me better thing, because, let me just write it here. Why is that so? Because limit 1 over secant 7 over 7x is a cosine 7x. This is cosine 3x. Now we have 0 over 0 indeterminate form, and definitely we can use L'Hopital's rule. And this will give me what? Negative 3 sine of 3x over negative cosine 7x. Yeah. And well, from here, okay. Oh, there's a 7 there. I missed that 7 here. Wow, I didn't differentiate this one. Sorry. This is the best one. Now, 3 pi and x approaches to pi over 2 from the negative side. Yeah. So, well, this goes away, and then limit of, well, actually, you can just go ahead and do this. This is 3 sine of 3 pi over 2 over 7 sine of 7 pi over 2. This is 3. Sine of 3 pi over 2 is negative 1. And for this one, we have, again, you see, if I have 4 pi over 2 is 1 2 pi, I can put it out, and it is again a negative 1, and that will give us 3 over 7. Turn the product indeterminate forms to 0 over 0 or infinity over infinity, and then use Labtube's rule to resolve that indeterminate.